Jai Hind. My name is Vivek Agarwal. I'm the assistant professor in the Department of Computer Science and Engineering of Akgec. So today we are having a topic that is KNN. The full form for the KNN is K nearest neighbors. It is an algorithm of machine learning which is based on the instance based learning. It is a special kind of learning. So let's start with the topic. We are going to discuss it in a detail with some numerical example as well. So before starting the main topic KNN, let's understand the some methods of learning. So this it is a part of inductive learning. The broader category is the inductive learning. Inductive learning is a broad area of the learning type where we are having a number of type of learnings as well as the number of algorithms. The general algorithms we are going to study, especially in the syllabus of this subject, most of the algorithms are the inductive learning. So it is also a part of inductive learning. I must say the instance learning is also a type of, or I must say the technique or the method in the inductive learning. Likewise, there is a model based learning. Initially, all the other algorithm we had gone through, like decision tree is there, regression is there, logistic regression is there, and some other techniques we had gone through, like naive Bayes is there. So all they are based on the model based learning. Model based learning works on the principle of whenever we get the training data, or I must say that whenever we are getting the experience data, the past experience data, what we do, we make a model, a learned model. Before starting the prediction, we just prepare a model which is based on the past experience data, which is trained. I must say that model is completely trained on the data we just supply to the system or the model. But in the case of instance based learning, this is not going to be happen, because in model based learning we are creating a model basis on the past data and large data set trained on the large data set. There's a set of rules we are going to find out. But in the case of instance based learning, this step is nothing. In this step, what we do, only just stored that data into the memory, which is going to be used in the future whenever we are having an instance for the prediction. In defined terms or in refined words, we can understand instance based learning do nothing. Whenever we supplied a data set to the model, to the system for making the model, nothing is going to be happen. Only that data is being stored in the memory. And now whenever we are getting a new instance to be predicted, like if we say there is a classification problem, we just supplied a new query, new data point to the system for classification, like to which class it must belong. So only then it will start working. Before that, nothing is happening in the system. So all the data is stored in the memory. Whenever the new point arrives, it gets started to work something, to find out the result basis, specialized basis on this current data point only. That's why the term is called instance based. Whenever this new instance is coming to the system, only that the learning is going to be started. So the basis of the learning is totally instance, the new instance you are going to predict. That's why it is called as the memory based learning also, because the whole data set we supplied earlier, that is residing in the memory, and for the all time it is residing in the memory. Like for particular instance, suppose D1, I just need to predict the D1, then the same procedure would be repeated. The new learning will start it on the basis of D1. But suppose D1 was 0, 0. The new prediction we need to make for the 0, 0. But now I just want to make the prediction of D2, suppose having the value 2, 2. Then it will start the learning, the fresh learning again on the basis of this new instance. So that's why the new instance, every time you are supplying your system, the every time the new learning is being happening on the basis of this particular instance and its values. So this is instance based learning, and the KNN is based on this model as well. So previously we just read about previously we read the various algorithm based on the model based learning, where we are splitting the data set into two parts, training and the testing part, and we were making the model trained over the training data set, training part of the data set. Then we were validating that trained model on the testing things. But here this part is missing. So if we understand uh, this whole thing, so there can be the two phases. Generally, for any ML algorithm, there used to be two phases, the training phases and the prediction phases. So in the case of training phases for the KNN, nothing is happening, making just there used to be two phases for any algorithm of the machine learning algorithm, training phases and the prediction phases. But in the case of KNN, there is no explicit training phase is being happening. There is no model is being prepared. So come to the point again. Sometimes it is called the lazy learning as well. Lazy learning. Just understand, I just supplied the model. I just supplied a data set to the model or the system for the requirement fulfilling of the past experience data, and that data is residing in the memory. Nothing has happened till now. No model is being prepared, no model is being executing, nothing is happening. The data is simply stored in the memory. Now the model, or I must say the system, is not being fetched, or I must say there was no query happened since many hours. So there is happening nothing. The model is kind in the lazy state. It is not doing anything. Simply it is lying on the bed, kind of the. So we generally called it the lazy learning, because the learning is so lazy. Whenever the new instance is coming, only then it is taking some actions. Another the point of the laziness is, like, if there are a huge, suppose there are 10 lakhs or 20 lakh instances which are stored in the memory, and the new instances arrive to the model for the prediction, then it is going to start take some action. Generally we do calculate the distance between the new instance and the old past experience instances. So if there are 10 lakh instances stored in the memory, so it will do the things, like if we talk about the distance calculation, it will have to do it for the 10 lakh times. So it is going to take a good amount of time to make all this happen. So in the case of huge data set, the learning could be the lazy. It could be the slower comparatively to the eager learning. And eager learning, the model based learning is called the eager learning, because in the complex system as well, or in the case of large data set as well, the model is constructed after the training phase. So whatever the time to be consumed, that used to be consumed in the training phases while the making the model. But when you are going to predict, there is no time taken process. Simply you just need to supply the query and the model will execute on the basis of its learning. Simply, no fresh calculation are going to be happen. That's why the model based learning are called as the eager learning, and the instance based learning are called as the lazy learning as well. So if I talk about the examples of instance based learning, these are the few instance based learning. KNN is one of them, very popular and widely accepted and widely applied for solving various problems. Comparatively very easy to implement, very easy to execute, and very easy to understand. That's why it's generally preferred by the designers, designers, ML model designers, for solving the various problems. So KNN is there, SOM is there, learning vector quantization is there, locally weighted learning is there, case-based learning is there. So today we are going to focus on this KNN and we'll understand the things using examples as well. So how it works? So already now you have a good idea, like whenever we are supplying the data to the model or to the system, nothing is happening, or neither data is being stored in the memory. So suppose we supplied a data set having data points of data of the two classes, class A and class B, class A and class B, which are represented using a color this yellow and this color green, right? So nothing is happening there, nothing, no model is being prepared here, no, I must say, no uh, any patterns are being identified just before we are not having this point. What is this? This is new data point or the new query point, which is need to be protected based on the past experience data already we have. So before KNN, we are having no idea about the classification things, but whenever we are having a new entry in the system awaken from the sleep and start working. So how it works, it find out some statistical calculation to all the data points available in the feature space, and after the calculation, whatever the results are there, on the basis of these results, it is classifying this new point, either this should belong to the class A or should belong to the class B. So this is the whole idea. Okay, so there are the three important things if we talk about the KNN. First is your distance matrix. Whenever we are having a new query point or the new query data into the system for the prediction, we will have to prepare our distance matrix. How it is being happening, or how it is being calculated, how it is being preparing, we will discuss a little later. So then the second important point is k neighbors. It works on the concept of this, like what actually is happening here. As the new, we are talking about the KNN, specifically KNN. So there are various techniques of the instance-based learning, and in this particular of KNN, it is based on the neighbor, as the name suggests, k nearest neighbors. So the classification or the, I must say, the solution of the classification problem or the judgment of the classification or the new class, expected class, or the prediction is totally based on the neighbors. But which neighbors? Like if we talk about the neighbors, it could be the nearby, just nearby neighbors. The circle of the neighborhood could be the, like this. If you are residing here, the circle of the neighborhood could be the this one of the few feet. Maybe the neighborhood could be of a few meters. Maybe the neighborhood may be of a few kilometers, and maybe a few miles. So it must be clarified what should be the criteria of the neighborhood. So we are talking about the nearest. Yes, nearest. So we are talking about, if this is your query point, then it's nearest neighbors, and the quantization or the quantity of the nearest, that is k. The very kth neighbors, they may lie in few feet, they may lie in few meters, they may lie in few kilometers, or they may lie in few miles. So whatever the criteria, but we are interested about the k. K is nothing, a number, a real number. It could be any integer. So if k is equal to 3, then we will have to identify the nearby 3. Suppose this, so nearby 1 is this, 2 is this, and 3 is this. Yes, if we talk about the nearest k is equal to 5, then we will have to identify 5 nearest point of this. So it could be 1, 2, 3, 4, and 5. So this is the whole idea of the k nearest. So how the algorithm is going to work? First, we need to identify the nearest data points. Nearest of who? The new query point. The new data point we want to predict its class. We will have to identify its neighbors. Then we will we will identify some patterns of the neighbors, and on that basis we are going to decide this new point should belong to which category. So what is the idea about this? Let's say if we are having the k is equal to 5, this is the new query point, and we need to identify the new neighbors. We identify the 1 2 3 4 5 neighbors, 5 closest neighbors or the nearest neighbors. Then we need to check their categories. So if we check, the category A is having the 3 neighbors and category B is having the 2 neighbors. So if we check the frequency, class A is having frequency 3 and class B is having the frequency is 2. So the frequency of class A is more than frequency of class B. So that's why the class A can be selected as the class, or the classification of this point can be done into the class A on the basis of measure frequency, right? So the third is prediction. So for the KNN, these are the three things. First, find out the distance. Only on the basis of distance we can quantify or we can analyze the nearest neighbors. So first important point is making a distance matrix, then selecting the k neighbors on the basis of this value k. It may be given or we can assume, and the prediction on the basis of this frequency, right? So let us sum up the things. So KNN is a type of supervised ML algo which can use for the classification and the regression. So in the case of classification, we can check the frequency on the basis of voting, and in the case of regression we can find an average using the mean or median, something like this. Any mathematical arithmetical model, we can find the average, but mainly it is designed for the classification problem. It is a lazy learning algorithm because what it do nothing. Whenever the data set is supplied to the system, it just stored the whole data into the memory, and whenever the new query point arrive to the system for prediction, only then it start with the things while calculating the distance and identifying the neighbors, and then calculating the frequency or the comparing the frequency of the class, etc. And third is non-parametric learning algorithm. It is a non-parametric algorithm because it doesn't assume anything about the underlying data set. Whatever the data set we are supplying, it uses it as it is, because there are various algorithms which are based on some assumptions. So this is not having such kind of things. Okay, let's understand using an example. So how the k is important. This is something just to understand the importance of factor k. Sometimes k is given in the problem, sometimes we will have to assume the k. So the value of k, what should be? There are two things. First of all, if you are having a binary classification, like the problem is given, we are having the binary classification, class A and class 2, there are only two classes. We need to classify the data either into class A or class B. So kind of the scenario is called binary classification. I believe already you know about it. So in the case of binary classification, this value k must be a odd value. Why so? If you are having a even, suppose if you are having a even k, if the value of k is even, suppose 4, and now after checking, class A having the frequency 2 and class B is also having the frequency 2, then there would be an ambiguous situation. So what to choose, because both are having the same frequency. So generally if you will keep it, suppose 5, so there are the at least one class would be having 3 and one class would be having 2 at least, or it could be the 2 or 3, it could be the 1 and 3, it could be the 0 and 4, sorry 1 and 4, and it could be the 0 and 5 as well. So whatever the scenario, there is going no tie between the two classes. So generally, ideally, we try to keep the value of k in a odd number if we are doing the binary classification. So what is happening? If we are having k is equal to 1, then the classified class for the new data point would be the class A. These are for the class A and these are for the class B. If we are having the k is equal to 7, then this circle is working. Then 3 are the for class A. The frequency of class A is 3 and the frequency of class B is 1, 2, 3, 4. So now its class is B. So in the case of k is equal to 1, class was A. Distinguished class for the new point was A. In the case of k7, the class become the class B. In the case of k is equal to 14, 2, 4, 5, 6, 7, 8. 8, then again the class become A. In the case of 21, class become again the B. 21, if you see, 1, 2, 3, 4, 5, 6, 7, 8, 9. The frequency is 9 and the frequency of class B is 12. So if you see, whenever you are changing the value of k, the prediction is also changing. So it's important to keep the value of k wisely. Another example to see the same thing. These are the points are given to us in the data set, which are colored in the red and the green of class A. Class A are colored with the red and class B is colored with the green, and the triangle and the star. So if we supplied a new point which should be predicted, its class should be the predicted. So if we are keeping the k is equal to 3, because the case is of the binary prediction, so we must keep the value of k a odd number. So for the k is equal to 3, the identified class is B. If we are keeping 7, then the class is A. So for the k is equal to 3, the class is B, and for the k is equal to 7, the class is equal to A again. So it is very important to decide the value of k very wisely. By default, the value of k is 5 in the KNN. So how the KNN works? Simply, every ML algorithm is executed into two phases, the training phase and the prediction phase. So in the training phase, general algorithms, what they do, they make a model, a trained model on the past experience data, a trained model. But in the case of KNN, no training is going to be happening. That's why no explicit training is going to be happen. There would be the, like we are interested in the training phase to have a model, but in the case of KNN, no model we are having here. But for the model, yes, we are having a system which can be called as a model, but there is no trained model to which we can call as the trained model. But in the case of model based learning, we are having a trained model. So this is the main difference we must understand. So in this phase, in this training phase, only the data set which is provided to the system for training purpose is going to be simply stored in the memory, which is going to be utilized only when the new point is being arrived to the system for prediction. Okay, so second phase is the prediction phase. In the prediction phase, we can have the 3 steps. In the prediction phase, we can separate it into 3 steps. First is compute the distance. As soon as we are having the new query point into the system for making the prediction, what I need to do, we just need to compute distances of this new point from all the existing instances. The new instances distance must be calculated from all other instances available in the memory. There used to be 3. There can be various tricks, various methods to calculate the distance, but we are very interested about the either Euclidean distance or the Manhattan distance or the Hamming distance. Generally, for the continuous variable, if the input features are having the value which are in the numbers, in integer or the float numbers, then we can use the Euclidean distance formula. And in categorical variables, we can use the Manhattan distance and the Hamming distance formula. So ideally, for having the integer values or the float values, or I must say the numeric values, we are going to have the Euclidean distance. So what is the formula? We will directly apply the formula, and we'll see the formula in the next upcoming example of the KNN. Then the distances are calculated. So suppose there are various points, data points, which are already residing in the memory, and this is the new point. I just calculated the distance of this new point to every point, and that distance is listed here. So we can identify the nearest neighbors. We need to find the neighbors, and which neighbors? The nearest neighbors. So for finding the nearest neighbor, we can align them in ascending or descending order as well, right? Now if we talk about the k nearest neighbors. So if k is equal to 5, we need to find out the points which are having the least distance from this new point, means the least values out of these various values, which are the least values, kth least value, yeah, k, or we must call it k least values of this tally. We need to figure it out, identify. Then what we need to do, third part is the making final prediction, that is based on the aggregation of the output. So for the case of, in the case of classification, what we need to do, we just need to check the frequency of the existing class, outcome classes, which can be done using the voting, which can be called as the voting system as well. So if there are k is equal to 5, so we will have to check all these 5 values to which classes they are being aligned. So suppose there could be class A and there could be class B. So 3 point could be belonging to the class A and 2 point could be the belonging to the class B. So if we see the frequency of class A is more than class B, or I can say the votes for the class A is higher than the class B. So A would be the as a winner, which can be attached with the queried value, which can be classified. The queried point could be, or instance could be classified as a class A. In the case of regression, because in the case of regression, there would be complete values. There would be no classification in the form of class A or class B. There would be continuous values would be there as an outcome. So what we can do, we can make the average of all these values, so that calculated average could be the outcome of that regression. So these are the important phases or the steps to be performed. So let's see one example. So we are having this a data set having few points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are the 10 input queries, or I must say the input data points in this particular data set, and we need to identify the class of a girl, Angelina, whose age is 5. So if we talk about the input features, there are the 2 input features. First input feature is this, which can be said as the x1, and or I must say the normal simple x, and this is your y, right? And we need to identify this Angelina, whose age is 5 and gender is girl. If we see, gender is quantified in the form of 0 and 1, which is given. 0 is for male and 1 for female, so it is 1. So 5 and 1, we will keep it like x1 and x2 for the betterment of applying the formula, distance formula. We will keep this y1 and y1, yes, and we can call all these values for the x2 and the y2. Simple. This is the outcome class. If you see, there are the few classes. Football is there, cricket is there, and neither is there. So the whole data set is of 3 classes. There are the 3 classes. So we need to identify this Angelina, whose age is 5 and gender is female, must belong to which class out of these 3 classes. So when are we going to apply? Simply, in the training phase, the whole data set is stored in the memory. Now directly come to the prediction phase, because we are having a new point, new instance to be predicted. So for that, we are using here the Euclidean distance. For that, the formula is something like this. The distance d is the whole under root. This under root is of whole under root of x2 minus x1 ka whole square plus y2 minus y1 ka whole square. So distance, if we see, the x1 is 5, x1 is equal to 5, and x2 is equal to, for in the case of Ajay, is 32, and y1 is equal to 1 and y2 is equal to 0. So directly supplying the values to the system, 5 minus 32 ka whole square plus 1 minus 0 ka whole square. On calculation, we are getting the value 27.02. Likewise, there is the whole table. Let's see what is going to be happen. So the new instance or the query instance was the 5 and 1, the x1 and the y1. Let's see what is happening. So it would be 40 minus 5 minus 40 or 40 minus 5, whatever you can keep it, because whole square bit make is positive value as well. So this would be the 35 plus 1 ka under root. So we can say under root of 36. This would be 11 and 0. So it would be under root of 11. It would be 34 minus 5. It would be 29, the whole square of 29. 55 minus 5 is goes to 50. 51, the whole square of 51. In this case, 35 and 1, 36. In this case, 20. 20 minus 5, 15. 15 and 1 minus 0, 15 under root. This would be 10 and 1 underscore 11, under root 11. 55 ke case mein, this would be under root 51, and the case of 15, again it is going to be under root 11. So after the calculation, these are the distances. As we calculated, this is the 27.02, and if we talk about mark, under root 36, which can be converted after the under root, the value is 35.01. This is the square. This is square, and square, right? Right. So likewise, we just have these values with us. In the case of 1, it would be complete 1, 1. This would be 50 k square plus 1. This would be 36 square. This could be 15. This could be the 15 k square plus 1. This could be complete 1. Nahin, only. ठीक है. This is 15 square. This would be the 11 square, 10 square plus 1. It would be 50 square. It would be the 50 square, because 1 minus 1 would be the 0. In the case of 15, this would be the 10 and 1. 10 k square plus 1. So after the calculation, we are having these values with us. So what we need to do? We need to do then identifying the neighbors. So in the given problem, we are having the value of k is equal to 3 is given with us. So we need to identify the 3 nearest neighbors. If we see the smallest distance is 10.5, 10.05, 10.05. These are the two common and can be considered as the K1 and the K2. After that, we are having this 11. So which can be considered as the K3. If we see their classes, in the case of Sarah, Smith and Michael. Sarah, Smith and Michael. Sarah is belonging to cricket. Smith is belonging to cricket, and Michelle is belonging to the football. So if we compare, the frequency of cricket is 2 and the frequency of football is 1. So if we talk about the voting, the cricket is having majority than football. So the outcome, the prediction class of the Angelina is as cricket, right? In the same way, we can do the things on this another example, which is having the two input features, the weight and the height. And these are the classes which are having the two classes, the underweight and the normal. So the prediction for this query can be solved using the same thing. So this is for your practice. Just try to make a practice using this example. I had solved this one, so I just need to clarify a few things. If we take k is equal to 3, suppose if we are having the k is equal to 3, after calculating the Euclidean distance, we are having these three neighbors, these three nearest neighbors. So the class of the whole 3 is normal, normal, normal. So frequency of the normal is highest and there is zero frequency of other class, that is underweight. So the outcome of this query point would be the normal. But if we take k is equal to 5, let's see what is going to be happen. In the case of k is equal to 5, then another nearest neighbor could be this, and after that could be this. If you see, its class is underweight and its class is underweight. So in the case of 3, we are having this, and in the case of k is equal to 5, what is we having? The frequency of normal is 3 and the frequency of underweight is equal to 2. Again, the prediction would be the same, but you can have an idea how the calculation is being done. So this is the summary of all the points already we had discussed. So thank you. This was all about the KNN.